everyone. Today I would like to share the topic servo motor using an LDR sensor with myRIO. So first of all, the servo motor. In case of the servo motor, it's included in the myRIO mechatronics kit. It has a feedback control system and it has a rotating part that rotate the shaft or spline to desired angle, and its motor wire refers the angular position command input, and the motor shaft included here the angular position response, and this is the motor wire that connected to the myRIO, the positive and ground, and another is the cable of the analog signal. That's a red cable connected here the VCC voltage, that 3.3 voltage, and another wire black the ground. It's connect the pin number 6 at myRIO, and the VCC voltage connect the pin number 1 and myRIO, and the white cable that's connect to the myRIO pin number 27, that's generate the input analog signal. So discuss about the servo motor application. It's acts as an actuator motor control. It's uses in robot arm or sensor scanner. It is also used in remote controlled airplane, and its main components of the servo motor. It's has the DC motor and control motor drive electronics also present here, and the command input. Here the red wire the DC power, and black wire it has the ground, and it has also present a gearbox with a shaft. That shaft changes the angle response. It has the high speed and low torque, whereas the spleen that's low speed and the high torque, it senses the spleen position as a voltage, and the features of this motor that angular position adjustable over a range of more than 180 degree. It has the pulse width position control. This pin number 27 is the myRIO that generates the pulse width modulation, that refers to the PWM signal that can be generated from the myRIO and transferred to the servo motor gearbox. Then it can be changed the position of the angle of the shaft in the servo motor. The total structural of the myRIO with servo motor, actually the command input response from the myRIO, and it's out given to the motor controller, and the controller act as an run motor as need to make actual position the same as intended position, then going to the DC motor, and after the DC motor the gearbox spleen angle response, that's the output response has to be generated. So this has the servo motor part, and again we use another to discuss about the photocell. The photocell component that acts as the operation of that resistance value changes with the luminances. The light incident on the cell, that's the changes of the resistance value, and it has a photocell, that's the components made with cadmium sulfide material, and it has a visible spectrum of the 400 to 700 nanometer. So discuss about the VI. So this is the block diagram of the photocell VI. The analog input that's connected to the myRIO B channel, pin number 3, and here is the photocell register, and the analog input voltage that can be generated, and the case structure also we here, and into the case structure the VI can be generated for the servo motor, the servo motor PWM channel, frequency, offset voltage, duty cycle, position, maximum position to be set as 100 as the condition is true, and after that duty cycle frequency, and that the reset myRIO. And if we change the condition as false, it has the minus 100 position. That's the position ranges actually minus 100 to plus 100 into the based on the photocell register's value, that can be moved to the angle and change the direction and also the position of the servo motor. And moving to the block diagram, moving to the front panel, here you can see the photocell the photocell here, and we can run the VI. Then you can see the direction of the photocell and the value of the photocell resistance ohm can be changed into the incident of the light. After the light of the free electrons comes to the photocell, the resistance value can be more increasing. So this is our demo project, that a servo motor with a LDR sensor using myRIO. So here are the presenter servo motor. That is the servo motor that connected with NI myRIO. Here is the 3 cable servo motor, red, black and white. Red is the cable, is VCC voltage, that's 3.3 voltage, and ground, that's the black color cable, and white color cable denotes the myRIO PWM signal that's connected to the myRIO B channel 27 number pin, and the VCC voltage connected to the myRIO pin number 1 B channel, and also the ground connected with myRIO pin numbers 3. So, and another component has been present, the LDR sensor. This one is the LDR sensor. It is a light dependent sensor, light dependent resistor also. Actually, its resistance value changes with illuminances, or you can say the light incident on that sensor, the resistance value increasing, and the connection having made to the breadboard diagram, the two 10k ohm resistance connected in serial, and then connected the sensor with the resistance in serial connection, and this is the wire that connected to the B channel myRIO PCC, and this is the this is the analog input voltage channel that refers to the LDR sensor input voltage, and this one has the ground connection. So this is our demo, and we can run this motor. Light begin incident on the LDR sensor, and changes the direction of the motor shaft. This is the servo motor, and this is the servo motor shaft or spleen, you can say. So the spleen actually move 0 degree to 180 degree over the range, and into the servo motor one DC motor and control board having present, so generating the PWM signal. So from LDR photocell into convert the resistance value, the voltage value, convert to the angle, and angle changes to the PWM signal. So into the PWM signal generating, and the motor shaft will be moved. We can run as a demo. So you can see the changing the angle of the motor shaft, incident the light onto the LDR sensor. So as per our project, this is our demo to the servo motor with LDR sensor using NI myRIO. It is a mechatronics kit of NI myRIO part. So thank you.